Very good morning. I am going to present a lecture on OLED. It is in the Physics for Electronics Engineering in the 4th unit, Optical Properties of the Materials. Here, the subject is PH8253, Physics for Electronics Engineering. Unit 4, Optical Properties. I am going to present the topic OLED. Here, OLED, it is nothing but organic light emitting diode. Here, organic compounds can be used as the emitting devices or the display devices. Okay, especially the organic light emitting diodes consists of these organic light emitting diodes consists of, I told you that, organic compounds, especially two famous organic compounds are there, AlQ3 and diamine. Here AlQ3 is nothing but tris-quinoline aluminum. It is nothing but an organic material, tris-quinoline aluminum, as well as diamine. Diamine consists of two NH2 compounds, NH2 groups attached to the benzene rings or attached to any organic groups. One such example is as shown here. It is one such diamine group. Here it is NH2. Here it is NH2. So, diamine groups. Then, these organic compounds are having semiconducting properties. That semiconducting properties are harnessed in the devising a device known as light emitting device. So, it is the outcome. This property is used to devise the OLED. Okay. Now, we are going to see what this device contains or consists. This device is made up of 4 different layers. One is the transparent glass as a window, transparent glass window, and another one is transparent anode, coated to the glass, and another one is your conductive layer, another one is emissive layer, here it is the cathode. Here, this anode is nothing but what your indium tin oxide. It is made up of indium tin oxide. Here, the dimension of this conductive layer is around 50 nanometer, and that of emissive layer is 20 nanometer. Here, this device is connected across the power supply. The anode to anode, it is always connected in forward bias mode. Anode to anode, anode to positive terminal of the battery, cathode to negative terminal of the battery. Now, here, if you observe this conductive layer and emissive layer is sandwiched between anode and cathode. Here, the purpose of anode is to inject holes into the conductive layer. Here, the cathode inject electrons into the emissive layer. Now, if you observe this device, the conductive layer has one property, or it is used for one purpose, that is hole transportive layer. It is used for hole transportation purpose. It is also known as hole transportive layer. Here, the emissive layer, it is having two purpose, or it is used for two purposes. Here, it will carry the electron or electron transport layer or electron transport region, and it enabled the recombination of the injected hole and the electron along the conductive emissive layer junction to render out the needed light output. Therefore, it has two purpose. It solves the two purpose. Now, if the power is switched on, anode injects hole into the conductive layer. Anode injects hole into the conductive layer. Similarly, cathode injects electrons into the emissive layer. Then these electrons are injected electrons go and occupy lower unoccupied molecular orbitals. Lower unoccupied molecular orbitals. For example, in ALQ3, for example, you are doing it as 1s2, 2s2, 2p6, 3s2, 3p6, and 3d10. 3d10, then 4s2. For example, it is 4s1. It is the lowest unoccupied one. It will be occupied by these electrons, and then in order to compensate the injected electrons, your cathode layer will get electrons from the battery. It will be occupying highest occupied molecular orbitals layers in the cathode layer. Now, the electrons will recombine with the holes along the junction and gives out the light radiation. This is the operation of your OLED device. Here, we can select the particular material for getting the particular wavelength as the output. By choosing the complexity or more and more complex materials, you can tune more and more fine tuning the frequency of the rendered light output. Then it is the cheapest one. Okay. Now, easily it can be fabricated. We are going to see the advantages of OLED one by one. Sir, it is cheap, easy to fabricate. Easy to fabricate means you can easily fabricate with your inkjet printer itself. It is a single colored OLED. It is possible with inkjet printer itself. Next one, flexible light emitting diodes or flexible display screens are possible with your OLED, and very high contrast, great colors. So perfect colors output can be possible. it is occupying or it is consuming least power supply when compared to LCD. Apart from that, the viewing angles are large when compared to LCD. Here, the disadvantages are, one of the major disadvantages are lesser lifetime. Second one, sir, these molecules can be affected by the moisture. So, water molecules can affect this. And third one, it is the costliest one. It is the costlier one compared to LED and LCD devices. Apart from that, advantages. While observing the advantages of time, flexible devices, flexible display devices, foldable displays, as well as camera, as well as cell phone display devices can be made with your OLED. And then flexible advertisement display boards are also possible with OLED. Thank you.